activity, we will be practicing Newton's 3 laws of motion. Who's Newton? Sir Isaac Newton was his name, and he was remembered for his discovery of the 3 laws of motion.
What are the 3 laws of motion?
The first law of motion is basically when an object is at rest, it will remain at rest unless acted on by a force. An object in motion continues in motion in the same speed and in the same direction unless acted on by a force. Okay kids, this is an example of inertia because right now it is not moving, which means it is at rest. It'll stay at rest until I apply force on it and move it, like that. My hand is applying force and is causing friction with the bar.
It's so easy.
It makes so much sense.
I totally understand.
Okay, so can you guys explain it in your own words now?
Okay, yeah, let's go to that trash can.
Okay.
So like this garbage can, it's at rest, and it's gonna stay at rest unless some force is applied to it and it moves it. Like if I like push it or like kick it.
Exactly.
Good job. Good job, guys.
Okay.
This handcuff thing is in motion, and it'll stay in motion until I stop it. So that's inertia, right, Hannah?
True. Good job. Okay guys, now let's move on to the second law of motion.
Yay! Wait, what's that?
Let me tell you. The second law states that acceleration is produced when a force acts on a mass. The greater the mass of the object being accelerated, the greater the amount of force needed to accelerate the object. An equation form known as A equals F over M. Okay, I know it sounds confusing, but it's actually really easy. Okay guys, stand up. For example, if I push you with a little force, you only accelerate a little bit. But if I push with a lot of force, he's accelerating a lot. Okay, so the less force, the less acceleration, and the more force, the more acceleration. So this proves that acceleration is directly proportional to force. So if I push you both with the same force I apply to one person, you will accelerate less because you guys are more massive together. So this proves that acceleration is inversely proportional to mass.
Oh my gosh, you're the best, Miss Hannah.
Yeah, you are. I totally understand.
Okay, so can you guys show me that you understand the second law of motion?
Okay, so as acceleration increases, so does the force, because it's directly proportional to it. So if I push this binder a little, it only accelerates a little. But if I push it a lot, it'll accelerate a lot.
Yeah, and then as mass increases, the acceleration decreases because they're inversely proportional. So if I push this massive bag with the same force that Sarah applied to the binder, it'll accelerate less because it's more massive.
Okay Okay, now we're going to move on to the third law of motion. What's that?
Yeah, can you go into more detail?
Okay, so it's basically, for every action, there's an equal and opposite reaction.
What? I
Okay,
don't
here.
understand.
Okay, here, let me show you. For example, this pole, if I'm pushing on it, it's pushing just as much force on my hand. So it's an equal reaction. And another example is if I'm resting on this rock climbing wall, my back is applying force to the wall, but the wall is applying back just as much force on my back. So can you restate the third law of motion for me?
Yeah. So basically, if I punch Sarah's arm, I'm sending a force into her arm.
And I'm applying the same amount of force back at your arm.
Yay! And that's all for the Newton's 3 laws of motion.
Let's go play! Woo!
My life is a series of actors changing places, except there's no backstage and there's no place for me. It's okay though, the jokes on the television make me laugh, remind me that it's okay not to have a backstage or a place to hide. But I've got dinner on my plate, got my paycheck yesterday. How great, how cool.
Okay, again. Okay, no. An object is at rest. It stays at rest until a force is acted upon by example of an.
You're not even listening.
Please, can you play somewhere else?
Okay, guys, come stand here. Come stand in this one. Okay, this one.